So quadratic formula is the most common approach that is used in solving quadratic equations, only next to factoring. The disadvantage of factoring is that you can't always factor a quadratic equation or a quadratic function, but the quadratic formula can be used to or with any quadratic equation. You may wonder as to why we did completing the square. We did that because quadratic formula comes from completing the square. So how? So we know ax squared plus bx plus c equals 0. Let's assume a is not equal to 1. So I'm trying to relate this to the process of completing the square. So let's just assume a not equal to 1, but do keep in mind the quadratic formula will work definitely when a is 1. So I'm going to divide both sides by a. Ax squared over a, bx over a, plus c over a equals 0 over a. The a's will get cancelled. X squared plus b divided by a times x plus c divided by a equals 0. Now, I can use completing the square. Okay. So I have b over a, and we have to divide that by 2 before we plug it in the box. So b over a divided by 2 is b over 2a. So b over 2a. Same goes in here, b over 2a. C over a. Now I will have x plus b over 2a square plus c over a minus b squared over 2a squared equals 0. So x plus b over 2a squared plus c over a minus b squared over 4a squared equals 0. We want to combine c over a and b squared over 4a squared. The only way that would happen is if we have a common denominator. In this case, the common denominator of the LCD would be 4a squared. So I want 4a squared over there. So I am going to multiply and divide c over a by 4a. So x plus b over 2a squared will be 4ac over 4a squared minus b squared over 4a squared. And that would equal to 0. So I'll end up having x plus b over 2a squared equals, move the other terms to the right hand side, negative b squared over 4a squared. When it moves to the right hand side, it would become b squared over 4a squared. 4ac over 4a squared, and it moves to the other side, it would become minus 4ac over 4a squared. We have a common denominator, 4a squared, and b squared minus 4ac. When combining the numerators. So a is a number, b is a number, c is a number. So when I put those values on the right hand side and simplify, I'm going to get a number on the right hand side. So I have a number on the right hand side and a perfect square on the left hand side. So I can simply take the square root on both sides. And of course, I'm going to put the plus or minus sign. The root and the square will get cancelled. Going to split the numerator and denominator root and write it as square root of b squared minus 4ac divided by square root of 4a squared. Square root of 4a squared, I can split it and write it as square root of 4 times square root of a squared. The root and the square will get cancelled. So x plus b over 2a would be equal to plus or minus square root of b squared minus 4ac divided by square root of 4 is 2, and I have a. As I mentioned earlier when we were completing the square, that we will know that we're getting the correct answer in completing the square if the denominator on the left-hand side matches the right-hand side, and it does. Now, all I have to do is to move the positive b over 2a to the other side. I get negative b over 2a, have a common denominator. So I can combine the numerators. And the final solutions are minus b plus root b squared minus 4ac divided by 2a, and minus b minus root b squared minus 4ac over 2a. And that is what we call the quadratic formula. With practice, oftentimes, most students will just remember this after doing it a couple of times or with good enough practice. So that is the quadratic formula. There is one important feature about the quadratic formula. We can determine the type of roots that we will get even before we start the problem. So what do I mean by that? We could either have roots that are real, undistinct, real, repeating, real, repeating, complex, both. So how do we determine this? Well, we have something called the discriminant. If we go back and look at the problems that we did, we got an imaginary answer because of the numerator in every single problem. It had a negative number. So the numerator, hopefully we have a case where we did not have I. So this is a case where the numerator did not have a negative. This is a case where the numerator was not negative, and same here. In this case, the numerator was negative, so we got a negative I. So in other words, the type of roots a quadratic equation will have is purely determined by that part, b squared minus 4ac. And that's what we call the discriminant. If that value is bigger than zero, just write it out. If it is greater than zero, we will have real roots and they are going to be distinct. If the discriminant is equal to zero, we will only have one root, and that's what we call a repeating root. If it is less than zero, then the roots are complex. And I wrote in parentheses as both, because if you have one root as a complex number, the other root must be its conjugate, period. So complex roots will always occur in conjugate pairs. So that is the quadratic formula.